Now that we know what one-to-one means, we can get into the meat of this lesson. If a function is one-to-one, meaning the x values don't repeat and the y values don't repeat, or if you're looking at the graph, it passes the vertical and horizontal line test. If a function is one-to-one, then it will have an inverse, and we write the inverse of f of x as the inverse of, f of -1 of x. So this does not mean this is an exponent, this is just notation. So we need to find the inverse of the following points here. And so we have f of -1. When you find the inverse, all we are doing is switching the x and y values. So my squiggly bracket, switch your x and y. So instead of this being -3, -27, now this ordered pair is -27, -3. Instead of this ordered pair being -2, -8, it is now -8, -2. Notice here when you switch it, nothing happens. The opposite of -1, -1 is still -1, -1. Same with 0, 0, and 1, 1. But then go back to switching here. Instead of 2, 8, now it is 8, 2. And instead of 3, 27, it is 27, 3. And then close with some squiggly brackets. Okay, I want to find the domain and the range of my function. So my domain of my function, remember domain is your x values. So we have -3, -2, -1, 0, 1, 2, and 3. Find the range of your function, which is your y. So squiggly bracket, -27, -8, -1, 0, 1, 8, 27. Now let's find the domain and the range of my inverse. This is still the x and this is still the y. That's a really good squiggly bracket, by the way. That's what I strive to do every time. Okay, the domain of my inverse is my x right here. So we get -27, -8, -1, 0, 1, 8, and 27. And then list the range of your inverse, which is the y. So -3, -2, -1, 0, 1, 2, 3. All right, what do we notice here? It looks to me like the domain and range, well, the domain of my inverse and the range of my function are the same, as well as the domain of my function and the range of my inverse are also the same. So that's what we're writing here. The domain of my function equals the domain of my function equals the range of my inverse, and the range of my function equals what? The domain of my inverse. So they switch. Now, using that same concept, we can graph inverse functions. The graph of a one-to-one function, f, and the graph of its inverse function, f to the -1, are symmetric with respect to the line y equals x. This is another key graph here where you just have that straight diagonal line. So example 4, the graph of a one-to-one function f is given. Draw the graph of the inverse function. For convenience and as a hint, the graph of y equals x is also given. So what I like to do here is to list my points. So for my function, I have the points -2, -2. I have 0, -1. I have 1, 0. And I also have 2.5. And I'm just listing the order pairs that they gave me. So then I know to find my inverse, all I need to do to these x and y coordinates is switch them. So -2, -2 doesn't change, but 0, -1 becomes -1, 0. 1, 0 becomes 0, 1. And 2, 1/2 becomes 1/2, 2. Now I'm going to plot those points. So 2, -2 doesn't change. Then I'll go -1, 0, 0, 1, and 1/2, 2. And so when I connect my dots, we get the same shape on the other side of my y equals x line. If you take this here and you fold it over, it's a mirror image of each other. So to go from function to inverse, you're just switching your x and y's.